And this is for making the silicone hot plate platform for a gas sensor. So we are doing a 3D model. First we have to select 3D and then next, and then we have to select solid mechanics. In structure mechanics, add, and then we also need joule heating. You can find that in heat transfer, electromagnetic heating, and then joule heating. These two we need in the beginning, then next, then stationary, then finish. And then we need to add materials. Open material browser, MEMS, semiconductors, silicon, add material, and then again add material. Again open material browser, MEMS, metals, platinum PT. Then we need to start doing. Then we are doing everything in mm right now, so we have to change the length to millimeters for easy calculation. And then right click on geometry and then block. The first block is 6 by 6, so we give the measurement 6. Height is 100 micrometer, so it's already in millimeters, so we type 100 e raised to minus 3. Then we center it and then build. So the first plate is built. Then we need a second block. Right click on geometry and make a second block. And the second dimensions of the second block is 2 mm, 0.6 mm, and then height is again 100 micrometer, so it's already in mm, so we type 100 e raised to minus 3, e minus 3. Then we also center it and then build all. And then we need 2 more blocks. The third one is the same as second one, so you can duplicate it. We need 1 more block for the platinum wire, and this width is 10, depth is 0.1, and the height is 10 micrometer. So here and put in a center, then build all. Okay, so everything is built. Now we have to realign all the blocks to using the coordinate axis. We can realign. I already aligned it, so I'll be just entering the values. Second one is x is equal to minus 4. Third one is x equal to 4. Okay, now we need to bring the platinum wire up. So by z 55 e minus 3. Okay, the platinum wire is up now. Now we need to assign the materials to each things. Silicon, and we need to enter the electric conductivity of silicon, which is 1 e minus 14. And then in And then for platinum we need to give the relative permittivity value. That will come later, we'll do that later. And then we need to assign silicon. All these three things are silicon. We can delete the platinum wire. So now everything except the platinum wire is selected as silicon material. And then for platinum we can choose this one, and now this is saved as platinum. And now we can give the relative permittivity, that is 1. Okay, now we need to start with the boundary conditions. The first condition is the beam ends of the beam should be fixed. So we take the model, we go to solid mechanics, click right button, fixed constraint, then zoom on this end. We select this, left click and right click so it becomes blue. Then we do it the same for the other side. Now the ends of the beams are fixed now. So now we need to give the ends of the beam as at room temperature. So we go to Joules heating, right click on Joules heating, then heat transfer, then temperature. So inside temperature we can select the areas where we should, where this is the room temperature by default, this is what we should give, but we should select this plane and the other plane. Okay, now we have given the temperature for the beams, ends of the beam. Now we have to give the heat flux to surrounding air. For that, in Joule heating, right click, heat transfer, heat flux. This is, I think this is the correct one. And the second one, which gives the formula W by m square K. And for H value you should give 5. And that's it. And the next thing you should do is we should give a voltage across the platinum leads. For that you have to go to Joule heating, right click, electric currents, the second option, and then electric potential. And inside the electric potential you can give voltage 2, and you need to show the current flow within the platinum wire. So you have to select one at end of the platinum wire. Here I'm giving 2 volts, that is saved. And then I need to give ground also. For that, right click on Joules heating, electric current, second electric current option, and then click ground. And inside ground just select the plane, the opposite plane, so that the 2 volts will be given across the platinum wires. So okay, now this is chosen as the ground. I need to save this one. Now we can simulate. Right click on study, then compute. For the temperature, this should be the temperature. The ends of the beams are at room temperature 293.15, and the part where the main silicon plate, where the main part of platinum wire is touching, will get heated. Only the platinum wire will conduct. The resistance of the platinum is like 1 milliohm. So voltage is 2 volts, the resistance is 1 milliohm. When you calculate the current, it is like 1000 amps. 1000 amps will be passing through here, if you think about it. Like, that's why it's getting heated up to 725 Kelvin. It's around 400 degrees Celsius. So I think this is the correct method. Everything is shown here. You can add another temperature graph in results. So 3D plot, and in 3D plot you can create a plot. And for 3D plot, for showing the temperature in another graph, you can right click on results, 3D plot group, then inside 3D plot group right click, and then go to volume, and then change the expression from solid to T for temperature, and units K will change to K, and then click plot. It will show the temperature difference in colors. We fixed the ends of the beams to room temperature, and this main center part will get heated from the platinum current flow. You can make more plots with current also. So this is the required output, I think. And if you want to add mesh, just right click on mesh and add free tetrahedral, and inside free tetrahedral click distribution, and there you can assign the corners, select the corners and give how many number of elements you want in a mesh, so that the mesh will change. That's it.